Hi, welcome to the tutorial on data exploration, independent numerical variables. By the end of this topic, you will be able to identify and treat missing values in independent variables. So far, we have been focusing solely on the target variable. We explored the target variable and drew out some observations and also learned how we can identify and treat the outliers and missing values in the target variable. We will now shift our focus on the independent variables and learn how to treat the missing values in the independent variables. There are mainly two ways of handling the missing values. These are deletion and imputation, and we have already seen them before. While we were dealing with the target variable sale price, we discussed that imputing the target variable is often frowned upon, as it can make the model learn from the derived data instead of the actual data. But in the case of independent variables, we generally use the method of imputation. Now, missing value imputation can be done using the mean or median for the continuous variables and the mode for the object variables. As our data contains both data types, let's have a look in order to determine in what ways we can impute the missing values for the different variables. So, let's import our dataset raw housing prices to.csv using pandas and import it as raw housing data. Once it is imported, let's check the data type of each column. For this, we use raw housing data.info. Now we can see that we have plenty of the independent variables in both numeric and object data types, but we are interested in variables which have missing values in them. As you can see, most of the missing values are present in the numeric data type and some in object data type. Now you might be wondering, these are quite a few independent variables to impute one by one using the method of median imputer. For this, we will be using the imputer class from the sklearn.preprocessing library. And to make things easier, we first gather all the numerical column names which need to be imputed in a single array variable. So let's focus on the numerical variables first and jump right into the code and see how we can do it. For this, we start by importing the simple imputer class from the module sklearn.impute. Next, we instantiate the imputer class with the parameters as shown on the screen. Now the missing value parameter specifies how the missing values are represented in our dataset. We will write NaN as our dataset contains missing values as NaN. The strategy parameter specifies the strategy we want to use to impute the missing values. We are using the median strategy here. Now that we have instantiated our imputer, we use it to impute all the numerical columns of raw housing data. In this line, we call the function fitTransform using the imputer instance that we have just created. We are passing the numerical underscore columns of the raw housing data to this function. Now, the function fitTransform is a two-step function. During the fitting phase, it calculates the median value with respect to every column that we have passed in as a parameter and stores it. In the transformation phase, the function does the actual action of locating the missing values and imputing them using the median strategy. So let's run this cell. The numerical underscore columns with missing values have been imputed using the median. Let's check it using the info function. You should be able to observe that all the numerical columns with missing values have been imputed and the number of values in those columns is 21,609. But we can see that zip code still has a missing value, as zip code should be treated as the categorical type. So let's quickly follow the same procedure as numerical columns and impute the zip code column. The most important thing to note is that strategy that we are using in this case is the most frequent, which is equivalent to mode. Let's run this cell by pressing Ctrl plus Enter. This was unexpected. If we look at the error closely, the function impute.fit expects two-dimensional array. So let's check out the shape of the column we are passing. Here, we can clearly see that the array we are passing is a single dimension array since there is no number mentioned after 21,609, which is the number of rows. A workaround that we can do is to reshape this. We reshape the column raw housing data zip code using values.reshape function. The syntax of the reshape function is reshape rows and columns. We have mentioned the number of columns as 1 and the rows as -1. -1 in this case signifies that the reshape function will adjust the number of rows by itself. So let's reshape this using the dataFrame.values.reshape function and check the resultant shape. Note that we are assigning the reshaped array to the variable column. Perfect. We explicitly mentioned the dimension of the array as one-dimensional. After reshaping, we follow the same procedure and we pass the column variable to the function fitTransform. So let's run this cell now. No error, which means our reshaping trick worked. Now let's check the dataset again using rawhousingdata.info. In the output, you can now see that all the missing values have been imputed in every independent variable. Note that we will be referring to the resultant dataset after missing value imputation as rawhousingprices3.csv, and the same has been provided in the helper text below. We would be using this file in subsequent videos. That's all for the imputation of missing values in independent variables. We will be looking at the variable transformation in the next tutorial.